So today we're going to look at other graphical representation of data. So we've already looked at our histogram. We've talked about how to create a frequency distribution table with different pieces like the class boundaries, the midpoint, cumulative frequency. So today we're going to talk again, still that there are different types of graphs. So we will discuss only some of the most common ones. The following is a description of the stem plot, the time series plot, and scatter plots. So stem and leaf plots. Leaf plots are useful for relatively small quantitative data sets, which don't have a large range of values. In a stem and leaf plot, the digits of each data value are divided into the stem and the leaf. The leaf is the final digit or the rightmost digit in the data set. So final digit is the rightmost digit, that's the leaf. The stem is all digits that precede the leaf, leftmost digit. So sometimes the stem can be 1 or 2 or even 3 digits depending on your data values. A stem and leaf plot is useful for showing your properties about data such as shape, center, and spread. No commas are used in a stem and leaf plot, and you need to create a key so the reader knows what the original data looked like. So with a stem and leaf plot, one of the benefits is you don't lose your original data. As like we saw with our frequency distribution class, is when we create these classes, all these numbers get lumped into a single class, but it doesn't tell us what the actual piece, the original piece of data was. So this one we can keep the original pieces of data and still sort of see the shape. So our first example, it says the heart rates for a sample of individuals after 30 minutes of exercise are shown below. Create a stem and leaf plot to organize the data. So the first thing that you want to do with a stem and leaf plot is sort of identify what's your smallest number and what's your largest number. So I look through my pieces of data. It looks like 73 is my smallest and 114 is my largest. So my stem part, right, is the digits that precede the leaf. So I look, right, the very last digit, that's my leaf part. So I'm going to start, right, so I have 73. So my leaf part is the 3. My stem part is going to be the 7. So I'm going to start at 7. If I think of the 114, the 4 is going to be my leaf part. The 11 is going to be my stem part. So we're going to go starting at 7 and go all the way down to 11. So 7, 8, 9, 10, and 11. So these pieces, these are my stem parts. So I'm going to create a line here and a line up here. So now what we're going to do is we're going to look at the leaf parts. So I look, and we try to put it in order just so that way it's a little bit easier to read. So I look at all my 7s, right, or the ones in 70. So I have a 73 and I have a 79. So my leaf part, I have a 3 here. No commas. We're going to leave a small little gap, small little space, and then put a 9. So this tells the reader I have a 73 and I have a 79 in my data set. So I like to just cross them off as I go so I know I don't miss any. Now I'm looking at the ones in the 80s. So the 80s I have 87, 84, and 86. So 84 is the first one. So I'm going to put 4 right under sort of where that 3 is. I then have an 86. And then I'm going to leave another sort of space and then put 87 or the 7. I'm going to do the same thing for the ones in the 90s. So I have a 98, I have a 93, and I have a 98. So I'm going to have a 3, and then I'm going to have 2 8s. And we do want to make sure we put them both down, because again, we're telling and we're looking at how many actual pieces of data we have. So any duplicates we would put in there. So if I look at the ones in the hundreds, I have 105, 110, and 100. So I have a 0 for the 100. So 0 is not just a placeholder. It is, let's see, the 100. And then I have the 105. And actually, I said the 110, but the 110 is going to be in the next one. So the 110, I'll have 110, and then my 4. So I have all my pieces of data. My last thing that we have to do is to tell the reader what the actual original pieces of data looked like. Sometimes you can use the stem and leaf plot for decimals, for whole numbers. So we want to put our key, and every book is different sort of where they put the key. I think ours likes to put it up at the top. So I can just put 7 and 3, sort of the very first one I put. We just tell the reader that it's equivalent to 73. Sort of an example, just if you had created this stem and leaf plot and had this little key here, you could say it's 7.3. So a key is very important, just so you know what the original data piece looked like. So another example. This has nothing to do with the one we just did, but just in case you ever encounter something that has a decimal, you can sort of go through and do that. So that is our stem and leaf plot.